If, say these tests that you ran on that load of concrete, what happens if it's not in spec?
Well, it depends. If it like the air was way off, if it's too low, then I can get some air right here and put in. I'll call the plant, let him know, hey, bump the air up a little bit on the next truck. If it's too high, we can always go back, pull the truck back underneath the plant, load a little bit more material on top of it. The more material you put on as far as cementitious and fly ash, it'll generally knock the air down a little bit. If it's too high, we throw it away. Slump wise goes the same way. If it's a little high, we can go back under the plant. Say it's say this was a 7-inch slump. We can pull it back underneath the plant. I can load a yard on top of it with no water in it, and in that way it dry the whole load up and get it back in spec. So you know, if we load a 9-yard load and we get it too wet and we put a yard on top of it to send to you, we don't charge you for 10 yards. You only get charged for 9 because that was our fault in the beginning. So you know, you get a bonus. But
so you're taking your samples for a highway project. This is not related to us, but a highway project, everything looks good now, and have you had it test out improperly later, like after you run your cylinder?
It could be. It could. 99% of the time, it's usually in somebody putting too much water in it or somebody mishandling the cylinders. Yeah. So, and in that case, if that happens, then we have to go in and run a remedial test. Yeah. Whether it's a Swiss hammer. A Swiss hammer's a device. I got one in the truck, I think. That it's got a plunger inside of it, and you push it down, and it's spring loaded, and when it gets to a certain point, it releases and it bounces. The more times it bounces, the stronger the concrete is. But it's only good when it's real smooth, like this trowel concrete. Out here where it's rough, it wouldn't do good. We also have a Windsor probe. A Windsor probe shoots a steel pin into the concrete. The deeper it goes in the concrete, the weaker the concrete is. If that's not accepted, then we'll have to go to coring, where we'll get a machine with a diamond core barrel, and we'll actually drill a core out of the concrete. Like this, if you want, and drill that core, and they'll trim it off, and we'll put it in the machine and crush it. And then it has to be at least 85% of design for cores, because of the whole process of coring. It generally weakens the core a little bit. So sometimes it depends. We've even seen it having to do a load test. Well, they'll actually have to come in and put a certain amount of tons of weight on the structure. If it's an auger cast pile for a bridge or something like that. So
when you run a core, you cut it to a certain length or something?
Yeah.
So you have a consistent test on it?
And if it's supposed to be a 2-to-1 ratio, twice the length of the diameter. Okay. If it's shorter, you can get by with a 1-to-1, but then you have a reduction. So if you break it and it's 4,000, it might only be 3,500 with that reduction. So if you find an issue, it's going to be on the very first load of the day. Materials change, so you always generally test the first load of the day to see what you have, and then you can make adjustments. Like this mix we just tested is a 3,000 fly ash commercial air mix. If I loaded a 4,000, he put, I don't know, say he put 3 ounces of air per yard in it, and he loads a 4,000, you're going to know he needs about 3.5, 3 3/4 ounces in it, because it's got a little bit more cementitious product, needs a little bit more air. So you don't have to necessarily test every different mix. You know, you can test one of a certain design. As long as you have things that are similar, you know what to do to make adjustments.